I'm Emily Probst, Senior Editor with Modern Machine Shop, and I'm here with Pete Zielinski, Editor-in-Chief of Modern Machine Shop. Pete, today I brought you here to talk about automation.
Right, automation. So a word that covers a lot, but if there is a theme or an idea that is the most important for manufacturers, for machine shops, for what we write about in Modern Machine Shop, it's automation.
So when you think about automation, Pete, oftentimes, at least I do, I think of automotive applications in which you make a lot of the same part over and over. But automation doesn't have to be that way. In fact, automation is becoming more and more common in machine shops for high-mix, low-volume work. Pete, can you tell me about automation being used in machine shops? Make the case for automation.
Yeah, so okay, automation. What do we mean by that? So robot is the first picture that comes to mind, but it means more than that. Automation could be machines that are able to do more in one setup, one handling. It also refers to other options for moving work around in and out of machines. Pallet systems, for example, refers to software that can automate certain operations. But I think the applicability of automation is changing. As you say, it's becoming more of an option for smaller facilities, smaller batches. But you asked about the case for automation, and I think the starting point there is what the case is not. Automation is not a replacement or an alternative for people. And the reason I say that is because the people in manufacturing who are apt to be most difficult to find are the high skill, high knowledge manufacturing employees, and really automation can't take the place of what they do. There's no way to automate the kind of value they bring to the process. So the case for automation really has more to do with augmenting, extending, amplifying what those high value people can do. So find every repetitive task that people like that might do and find ways to automate that to set them free for the higher value work, of which there's plenty to do. And then there's also a broader possibility of extending the work of the whole facility as well by allowing production to continue maybe into nighttime hours where otherwise that capacity is going unused because all of the people have gone home. And I think as we talk about this, we'll have to get into into unattended machining. Sure. But I think there's a more basic starting point, right? There's different levels of automation technology. Can you speak to that?
So yeah, different levels of automation. The key with automation is to start small. And I think a lot of shops get cold feet really when they start thinking of automation. They think, oh my goodness, I have got to get a systems integrator. I've got to get a specialized person on the shop floor. I've got to think of this big complicated nightmare and I've got to get it solved right now, right today. But that's not the case. Machine shops can start small with automation. And one of the ways to do that is to, for example, start with quick change work holding. And from there, maybe they bump into using a robotic loader and a pallet pool, and then you can do offline setup. And then from there, that's when you can jump into integrated robotic systems. And so the key is to start small and then set it up step by step by step. And there's a roadmap, if you will.
Yeah, roadmap's the right word for it,
yeah.
Right? It is possible to start very small and very basic with automation. In fact, I think the most important innovations in automation technology right now are at the low end, are at the basic end. Cobots are maybe the most obvious example of that. Collaborative automation makes it relatively simple to automate an existing machine, an existing process, maybe even a machine that's considered to be one of the lower value pieces of equipment in the facility. Mm-hmm. But the potential advantage and starting point that brings is the chance to establish the rhythm for automation, see its benefits, begin to see from there other potential wins for automation in the facility, in the process, and begin to expand the use of automation out from there. And there are technologies and techniques in parallel that can help facilitate and guide that advance of automation. One of these is just a culture of systemization and continuous improvement, which some manufacturers really have to a high degree. The habit of defining and systemizing every operation in the facility makes it that much easier to see exactly how to plug in automation and what steps that it should do. Similarly, machine monitoring is a very important technology here, a very valuable technology. Monitoring plant-wide how all of the machines are performing for a holistic view of all that performance together, because a machine monitoring system can expose where there are gaps of downtime, maybe inevitable downtime because someone had to walk away for something else that had to be done, and are these gaps that could be bridged with automation. But I think the important thing in all of this is the advance I'm describing, the journey I'm describing. We've associated that with big plants, big factories for a long time, but that journey now is accessible to job shops.
So as a practical matter, it just doesn't seem to work for automation to be used in job shops, right? High mix, low volume just doesn't seem to work. So then you're left with the question of how do you take a highly unstandardized process and make it something that's standardized? And the way to do that is to come up with a common thread. Now, oftentimes this common thread is work holding, right? So take, for example, a shop that has a lot of different size parts, but these parts can all fit in a standard size vise. So in that situation, a robot can then grip the vise, not the part, but the vise, and load the machine from there. And in a way, it's automation trickery, right? Mm-hmm. From the robot's perspective, the robot is loading the same thing over and over. Another common thread would be the finding the part families, right? Finding the same size, same shape of part, and coming up with these part families that you could then run on a complex machining cell. Now, a job shop is going to cringe at that thought. Why would I use a complex machining cell for fairly uncomplicated parts, right? But the answer to that is you want to use your skilled machinist to run a standalone machine for these complicated parts. And by having that happen, your unattended machining grows, and as that grows, as your shop becomes more comfortable with it, maybe that's a case for lights out machining.
Yeah, right. So that's a great picture that you paint there. Is there's maybe an argument for sophisticated equipment doing simple work so that sophisticated employees can do the more complicated, higher touch manufacturing. And yeah, there is a transition from there into lights out. And I think that might be the biggest idea, the most important promise in automation right now for American manufacturers, because there is in many facilities this untapped resource in the form of the equipment that is not being used, that is idle during the nighttime hours. It is not necessary to send work far away in search of lower cost production, because a whole lot of facilities have the equivalent of this low cost manufacturing partner that's in the same building just at different hours of the day.
Yeah.
And the path toward that is automation that becomes so trusted because it is so proven and reliable and works so well and so frequently within the daytime hours, that the natural extension of that is to allow it to just continue after hours and keep on producing into the night. We're already seeing this to some extent, but I think what's increasingly going to be the case in machining in North America is that facilities are going to divide the work they get into, here is the kind of repetitive, very automatable work that I do at night, and here is the more challenging work that I need my skilled employees to work on during the daytime hours. Again, with those employees augmented and amplified, supported by automation, even during the day. So really, it's an even bigger scale way to amplify the work of these skilled people, because it is their knowledge that ultimately allowed these automated systems to be established, proven out to such an extent that those systems could keep on running when the people temporarily go home for the night. And that brings it back around to the human element in this. And I wonder, could you talk about that, just the human factor in automation?
Yeah. So the human factor in automation, man, that's a hot topic right there. You've got one school of thought that says automation is taking jobs. And then you've got the other school of thought that says, actually, it is encouraging people to come work for my company, and it is keeping them there longer. And regardless of your school of thought, automation is transforming human jobs, oftentimes for the better. So say, for example, that there is a job that, man, every guy on the shop floor, they just hate doing. Maybe that's a good one to eye for automation. Or there's the common example of the repetitive task, the task that hurts your machine operators. Those are all good examples for automation. The key is you want to use your humans for challenging jobs. You want to use their mind. You want them thinking about, how can I improve this task? How can I benefit my machine shop? How can I think through this problem and make things better? By challenging your employees in that way, you mentally stimulate them, and a challenged employee is one who will stay.
Yeah, so people is what we're really talking about. When we talk about automation, we're talking in large part about keeping people productive, as you say, and keeping people engaged.
All right, so let's wrap this up. Automation, it's not as big and complicated as you might think. It's actually good for job shops with high mix, low volume, if you start small and build out from there. And while you're doing so, make sure to keep people at the heart of your process. So, I'm Emily Probst.
And Pete Zielinski.
Thanks for watching.